Today, we'll be going over how to use the Poisson distribution in a real-life scenario and show how it can be used in advanced situations and not just typical comparisons between two Poisson distributions, but have real applications in the real world. And in this example, we'll be using it for a restaurant. A restaurant will only offer deliveries if they have spare staff available to prepare the food. This only occurs when the amount of people current in the restaurant is below the monthly average of the restaurant. Find out if the restaurant can offer deliveries today. So, the first thing we need to be able to do is see how many people are in the restaurant currently and if they have spare staff. Now, from previous calculations, we already know that the monthly average is 11 people. So we need the current amount of customers to be less than 11. And to do this, we'll be using MatDeck's Python call function. MatDeck's Python call function allows us to directly utilize Python code and its subroutines or functions inside a MatDeck document natively. This means that we can combine our Python code, which we have previously written, with MatDeck 2D as well as 3D graphs and a plethora of functions all on a live document and not just a script. In this example, we're going to be using the fetch data function. Now, the fetch data function is defined here in Python. As you can see, we use the Python request library to utilize a URL and receive data from it in the form of JSON. After that, we read through the data and make sure to only realize what information we need, which is the current number of people in the restaurant. Now, if we were to go back to our live document, we can see that we store this in a variable called current, and we then use this current variable to plot a Poisson distribution in this graph here. Now, with MatDeck, all we need to do is simply add this daily variable, which holds the Poisson distribution with the current amount of people on it. To do that, all we need to do is go add variable and click daily. Now, as we can see, the Poisson model has a lower amount of current people than our monthly average. And, more importantly, the chance of it having more than our monthly average is lower. As we can see, the probability where the two lines intersect is only 10% or 0.105. Now, if this were data to change, it would be refreshed. We can also use the evaluate button to change the data and see if the amount of people in the restaurant has changed. However, as we can see, the amount of people in the restaurant is still 7. And this means that the staff are able to offer deliveries as there is less than the monthly average.